In the last video, we did some basic configurations on Betaflight for our quad, and this video we're gonna bind our transmitter. I'm gonna be using the Radiomaster TX16S, and we're gonna set up the aux modes and pretty much the basic setup for binding your transmitter to your receiver and the basic arm and preamp switches you need to get it in the air. So without further ado, let's get into it.
257.
In the last video, we kind of finished up the Betaflight configuration about the OSD and the VTX. Pretty much the basic configurations. In this video, what we're going to do is we're going to bind this receiver over to our transmitter. I'm going to be using the Radiomaster TX16S. I'm going to show you how to set up a basic model on the transmitter, which is pretty much similar to any OpenTX based radio. Radiomaster TX16S, the Jumper T16, T18s, any of the FreeSky receivers. Probably somewhat similar to the TBS Tango as well. I'm not going to do the advanced setup, which is how usually I do all of my quads. So I basically use just one aux channel to map out every function that I need to do on the radio. Again, it has its own pros and cons, but I feel like that's what I do. That's what I need to do, and I'm not gonna cover that in this particular video. We're gonna probably do another video for that. But in this video, all I'm gonna do is set up basic arm, preamp, a couple of modes, like the angle mode or the acro mode and stuff. So it's just gonna be the basic setup. The first, we're gonna have to bind our receiver to our transmitter. Before that, let's set up a model on our receiver. Let me just zoom in to the screen. The way we set up models in a Radiomaster TX16S is you press and hold the jog wheel, select model select, and again press and hold, create model. You can just hit the exit button at this point and a new model is created and it is selected. So what we want to do is click on that. Now exit. We're already selected on the model that we just created. Press and hold on the model button on the right. It goes into the model name setup. Again, you can rename the model's name. I'm gonna leave it right. Hit the page button and go to the mixes page. Yeah. As you can see, the first 4 channels are already mapped out for the ailerons, basically your stick commands, your throttle, aileron, rudder, and pitch, yaw, roll, and the throttle. So what I'm gonna do is I'm gonna set up 3 more channels, one for prearm, and the source is gonna be the momentary switch at the end. I'm gonna use this momentary switch for prearm, and the way it selects is just go to the source, just click on the source and just push on, just change the position of the switch that you want that source to take on and automatically select it, and that's it, just go out. So that's the preamp switch setup. Channel 6, I'm gonna use it for arm, and the one that I'm gonna be using for mode is this switch B. So I'm just gonna move this, it's gonna get selected, and that's pretty much it. These are the 3 basic modes, basic aux channels that you will need for in order to get your quad up in the air. And we can exit this at this point, and what we're gonna do is go to the model page. In the first page, scroll up to the, where is it? Internal RF. Right now it's set to off. I'm gonna switch it to multi and FreeSky, and I'm gonna leave it at D16 mode because that's what I'm gonna be using. channel 1 to 16, receiver number 00, doesn't matter because again, I'm not going to be using the model mapping, so I'm going to bind all my receivers in the model just using one number. Maybe if that's confusing, just give it a number and just click on bind. At this point, the radio should start chirping. Put it aside, and we're gonna have to put the quad into bind mode. And the way we do that is we have to power up the quad while holding down this bind button. There's a tiny button on the receiver which you have to hold it on and then plug in the battery, because the diatone Mamba stacks do not power up the receiver via USB. So you have to power up the battery, and then again, you get it, right? You need two hands to plug in the battery because the battery has an XT60 plug, and you need to hold the XT60 plug on the quad in order to connect it, which is kind of difficult because at the same time you need to push on this bind button. So here's what I do. I have this whole concoction of a thing, which is basically a switch routed between an XT60 female and the male plug. I know I'm gonna come up with a better design. I have a 3D printer. I'm working on a design to like miniaturize this, also incorporate the smoke stopper. So I'm not gonna use the smoke stopper right now because I am sure that everything is working fine, which I confirmed it while doing the bench test. So the way it works is the switch has a female XT60 plug where it takes the battery, and the male plug goes on to the quad. You see, but the quad is still not turned on because I still need to flip the switch, which is kind of cool. Right now, what I can do is just push on the bind button and turn on the quad. Now there you go. It's in bind mode. You see both the red and green LEDs. I don't think you'll be able to see it on the camera, but there's like both red and green LEDs turned on the receiver. At this point, you're gonna take the receiver on the radio and click on the bind button. And I don't know if you guys can see this, but there's an LED. There's a red LED on the receiver which is blinking, which means that the bind was successful. And the chirping on the radio will stop. At this point, you just power cycle your quad. Now, just the green light is solid, which means we have bound our quad, we have bound our receiver to our radio. So there's another way you can verify that. As you can see on my radio, I see the telemetry button. Now if I turn off, I should get a sound alarm saying that telemetry is lost. Telemetry lost. There we go. It means the quad was connected to the radio. So at this point, our job at the bench is done. We have to go to Betaflight in order to set up the aux modes on the flight controller so it can read the channel inputs and outputs from the radio. Let's head over to our computer and finish that setup. Okay, welcome back. Now that we have bound our receiver to our radio and we've set up the aux channels on our radio, it's time to map these aux channels in Betaflight and tell the flight controller what it needs to do when it gets a command from the radio. So let's move on. Let's connect our flight controller to the computer. Quad is connected. Connect the battery. It is bound. There you go. I see stick movements. So yeah, we should be good. So first we're gonna go to the modes tab. We're gonna set up 3 aux channels, one for pre-arm, one for arm, and one for the different modes. Usually in Betaflight, when you select auto and just make sure the aux channel is doing something, this tab should populate that aux switch. I mean, in this case, which it's not. So I'm gonna select aux 2 because that's what we set the arm switch on. You see the slider moving across, and all you have to do is see this orange pointer thing, and you want this block to be on top of it which means this mode is active. At this point, if I save, it's gonna say armed, but it's disabled because right now the quad is connected to the computer. But if it weren't, it means that it would be the quad would arm at this position. That is exactly what I want, because I want this switch to be away from me to arm the quad and towards me to disable, because if I'm flying like this, I'd rather arm the switch and keep flying, and if I wanted to disarm, all I have to do is just this. That's good. So arm switch is done. Next I'm gonna set up a pre-arm switch. Oh, there you go, pre-arm. Click on add range. I wonder why this isn't working. This is going to be aux 1, and when I pull the switch towards me, that's going to be the pre-arm activation mode. And I'm going to drag this all the way out here and reduce this a bit. You need to make sure the pointer is within this orange slider. That means the pre-arm is active. So if I click save, see, pre-arm is active right now. So the way pre-arm works is, at this point, let me go back to the top. See, arm switch. Now if I click the arm, it's still disabled because it's not going to let you arm without a pre-arm. This is how it's going to be arming. It's called two-switch arming. It's a lot more safer, because if you're carrying your quad and accidentally the switch gets tugged on to your maybe a camera buckle or your bag or even your hands, you don't want the quad to like arm when you don't want it, because if there's two switches involved, the chances of accidentally arming the quad when you don't want it is pretty low, because you have to manually hold this momentary switch and then flip the arm switch. That's the only time when it arms. That's the basic safety protocol that I use when setting up arming. Now to the modes. Let's set up angle mode, which is basically the auto level mode, and I'm gonna be using the aux 3 for that. And I want the angle mode to be in the middle position of this switch. So you see how the slider is, the orange pointer is going to 3 positions. I want the middle position to be for angle mode. I don't know if you guys saw that. So this middle position of the switch is what I want to be angle mode. So I'm going to put it in the middle switch, and I'm going to drag the slider to cover the area for that marks the middle position of the switch. Click save. Now the quad is in angle mode. Now if I flip the switch up, it's out of angle mode. I'm going to leave this to be the acro mode, and I'm going to set up one more mode. By default the quad is in acro mode, and if I flip this switch to the middle position, it sets it up as it puts the quad into angle mode. And down position we still haven't configured it yet, but I say the top position, I'm going to leave it default to acro mode. Finally, I want to set up a where is that? Flip over crash mode. So what this mode does is, if your quad is before that, I'm going to use the bottom position of the switch for the flip over crash, or it's also called the turtle mode. Probably because turtles can, if the turtles get flipped over, they can just, I don't know, wiggle their way and right side up again. That's basically what this mode is. So if your quad is upside down, it kind of puts the motors into a reverse spinning cycle, and you could just throttle your way up to like flip the quad over. That's what it says, flip over crash. And the bottom position for the switch B is going to be the flip over crash. The center position is going to be the angle mode, and top position is nothing's activated, which means it's in acro mode. So let's recap: arm switch, pre-arm, angle mode, and turtle mode. That's basically it. We have configured our controller for now. Let's do a test. There's 2 tests we need to do: disconnect it from Betaflight, disconnect from USB. Power cycle to be safe.
Telemetry lost. Telemetry recovered.
Now, let's see if the quad gets armed. Basically, it should not arm right now if I just flip the arm switch, which it doesn't, because we still haven't used the pre-arm. Now, let's do the pre-arm. Why is it so difficult? Okay, pre-arm active and arm. It's not arming. I wonder why. Throttle, maybe. There you go. Quad is armed. You hear that? And we don't want to move the quad right now because the gyro is active and the pid loop controller is active. I hope you guys hear the motor spinning. But yeah, the arm worked. Second thing we want to test is the fail-safe. At this point, I don't know if the fail-safe is set or not. Let me disarm first. I think I forgot how to set up a fail-safe. After we bind the receiver to the radio, we should set up a fail-safe. It means at any point, if the quad loses connection from the radio, what it should do. Basically, it should just fall out of the sky. So if you go to the model screen, scroll down or up based on what you want to do. After, it's gonna be in the internal RF section. Scroll down to fail-safe mode, click on it, and just scroll around to no pulses. Yeah, that's pretty much, it says that the quad, it pretty much tells the quad that if you fail safe, just don't do anything, just drop out of the sky. That's what no pulses is. That's how you set up failsafe. Now that we have successfully set up the failsafe, let's see if the failsafe works. Arm the quad and just turn off the receiver.
Receiver still connected.
It'll give you a warning, but just say okay. There you go, the quad stopped. So the failsafe works too. So that's pretty much it. The radio is set up, it is bound to the receiver on the quad, and we know how to arm the quad. We got a couple of modes set up, and we're almost done. It's now time to just put everything together and try to get the quad in the air. So let's head back to the workbench and let's put it all together. Betaflight configuration is done, the motor mapping is done, the motor directions check, video transmitter, OSD, binding to the radio, aux modes, check, and check. So the only thing that's remaining is putting it all together. Also, if you guys notice from our last video on the workbench, there are a couple of things that are different. I have kind of stuck the I have wrapped the VTX with some Kapton tape. Any electrical tape that you have lying around in the house will work, but I like the Kapton tape because this is highly heat resistant and is electrically insulating as well. So I wrapped it in Kapton tape and just stuck it to the frame with some double-sided tape. I use Gorilla tape. You could use whatever you want, but use pretty high quality or strong double-sided tape because you do not want your VTX to be flopping around. Same thing with the receiver. I have stuck it with double-sided tape. Also, I have used a couple of zip ties to secure it to the frame. I just passed it through the slots that's already there in the frame. The zip ties also do a good job of holding down the SMA pigtail that is coming out of the VTX, if you guys can see this. So, and also at the end of the quad, I have used two zip ties in X format to hold the SMA pigtail onto the frame. Also, make sure the zip tails are putting pressure on the coaxial cable itself, not the connector. So in a crash, there's some flexibility. The coax cable is flexible, the joint is not. So do not try to fix this joint onto the frame or even this SMA connector, because this is conductive and you don't want the signal to be leaking into the frame because the carbon fiber frame is conductive as well. So I have zip tied onto the coax cable it also gives some flexibility in case of any crashes. That's the only thing that I have done. Now let's put on the rest of the stuff and let's fix everything up. We're gonna need the standoffs that came in with the frame kit, and we're gonna be using the rest of the screws that came in with the frame. Take these all out. So it's gonna take 1, 2, 3, 4, 5, 6, 7, 8 standoffs. Do we have 8? Yes, we have. So find the right size bit for the screws. Make sure you don't pinch any wires when you're connecting these standoffs. The thing with these hex screws is, like, sometimes when you over tighten them, the bit or the screwdriver gets stuck inside the head like this. If I over tighten them and if I try to pull it out, the bit is stuck in there. So at this point, don't try to wiggle it out. So if you're the clockwise righty tighty, right, all you have to do is turn it a little bit to the left and just put the screwdriver and just turn it a little bit to the left and it just comes out. Don't try to wiggle it out because you're going to strip the screw heads. You don't want that either. There you go. All standoffs are done. Now let's see how we fit the camera. The camera came with these mounting equipments. Let's get it all out. So these are universal sizes depending on what size of lens you're using. So I am guessing the small one will do for us. This is too small. This I think is too big. Is it? I guess this will work. I don't know how secure this is though. Can we use the plate that came with the camera? Is this gonna be more secure? Yeah. We'll need some nuts for that. Yeah, let's just do this. Now, before we lock on the top plates, what I like to do is secure up the motor wires with some electrical tape. I know some people like to use zip ties, but I just feel like electrical tape does the best job. Now, since this has a lot of red going, I'm just gonna use red tape. Does not work. The camera is loose and it doesn't seem to be wanting to get the up tilt. So what do we do? Okay, looks good. What else? I'm gonna use this silicone battery anti-skid pad on top. So it's basically a rubberized material which kind of goes on top of the frame, so that when you put your battery on top of your frame, the battery is sitting about 2 millimeters above the frame, and also it's not going to be digging into these screw heads. You don't have to use it. It just makes the battery adhere to the frame. Like, it's not going to just slip out. Like, you see this battery, right? I mean, it's just plastic, so it's going to slip around. If you don't want that, you can use this. Again, you don't have to, but I like to. There you go. Now the battery can sit without slipping. Now, what else? We definitely need to put props on, but for the XT60 lead, all I'm gonna do is take a zip tie, maybe two, and I am going to zip tie it to the standoff. Probably do a couple. It's really hard to do it while showing it to you guys. So all I'm doing is, you see the side standoff? I'm just zip tying the XT60 lead. Once at the bottom and probably once at the top. So this is good enough XT60 lead that I want. Don't crush the wires, just snug enough so that it won't come out. Cut the excess. And I'm gonna use one more zip tie to secure it close to the top, and we should be good to go. There we go, almost ready. Now the only thing remaining is to put the props on and take it out for a spin. Let's see how it looks. There you go. Looks decent, doesn't it? For $99 and some change here and there. Looks pretty good. Looks pretty darn good. Oh, we also have these skid pads that came in with the frame, so I might as well use it. So in my experience, these skid pads kind of wear out pretty easy, so I like to tape them up so that they just last a wee bit longer. Can't find black tape. I'm gonna use black tape for this because I don't want too much red. There you go. Good to go. Let's put some props on. Now remember how we talked about counterclockwise, counterclockwise, clockwise, clockwise. Counterclockwise, counterclockwise, clockwise, and clockwise. We got good clearance all around. Let's put some props on. About the receiver antennas, I like to use these antenna tubes. I know Joshua Bardwell doesn't, but again, if you want to use antenna tubes, you really should have a 3D printed part that is especially made to hold those antennas. Otherwise, they're just gonna flop around and fall off. So I'm gonna do what Joshua Bardwell suggests, even though I don't like it. So what we do is we tie around zip ties onto the legs of the standoffs. Don't cut anything yet. Angle it around a little bit. And so we want this to be like really tight. It's not just okay. Yeah, that should be good. Another one. We're gonna go this. And at this point, what you want to do is you want to run the antennas along the zip tie, and I'm gonna use heat shrink. But if you don't have heat shrink tubes, what you can do is just tape it around. Just tape it around your zip ties. That's good enough. And make sure this part, this exposed part, this is the real antenna. This is just insulation. This part should be protected. So run it along, use some tape, or in my case, I'm gonna use heat shrink tubes to be specific. And trusty flamethrower to heat shrink the stuff. And make sure when you heat shrink something, you do it from both the sides. That's it. The quad is complete. It's flight worthy, or is it? Maybe. Well, only time will tell. So yeah, next video we're gonna go out, do a test flight, and until then, peace.